Oh, hello to our latest guests. We're happy to see a lot of people joining for this is the third meetup, remote meetup. We had a meetup on Vue, we had one on Angular, so the natural order dictates that the third one is on React. Hopefully the next ones will not necessarily be in the same for front end frameworks. We'll try to diversify the topics also. This was not necessarily arranged this way, it's just a coincidence. Yeah, we're going to announce the meetup for next week just after this one. It seems that the recurrence, like one meetup per week, works because people are interested. We have a lot of topics that we can bring here, and we have this benefit of being able to invite people from all over the world to present in front of the community this way. We're going to try to bring speakers that were supposed to be in April in Cluj for JSHeroes. We're going to try to bring them into some of the meetups also in the coming weeks, months, depending on how long the situation is going to remain like this. And of course, if this is successful on the long run, even if we go back to organizing, regular on-site meetups, we will consider doing once in a while a remote one also. It's also much easier from the logistic perspective, but of course you're missing some part of the fun and networking. We could try also the networking afterwards and see how it works if people want to stick around after the presentation. So today we have another Andrei. Last week we had Andrei Antal. This week we have Andrei Pfeiffer joining us from Timisoara. Andrei is, could say already, he's an old friend of mine because I don't remember, like we met 3 or 4 years ago already.
Yeah, something like that.
Something like that. He's been to Cluj, I've been to Timisoara. We supported each other with the communities. I'm not sure if he's gonna talk about this, but their community in Timisoara is actually the longest living community, JavaScript community in the country. And we had a lot of interesting ideas, exchanges, a lot of good points taken from each other. And yeah, I guess he will speak a bit also about maybe revo.js, their conference that they're organizing hopefully in October. Yeah, finger crossed. And yeah, I guess that's all from my side. Andrei, you can start whenever you're ready.
Yeah, thanks Alex, and thank you JSHeroes community for putting this event together, and thank you all for attending this event. So let me put myself here. Okay, so as probably many of you know, next week, at the end of next week, JSHeroes was supposed to take place, a conference that I wanted to attend, and probably many of you as well. Unfortunately, that's not happening anymore. And one day before the conference, on the 22nd of April, I was supposed to have a workshop along with other friends, a workshop about React rendering performance optimizations. So just to give you a bit of a context about today's presentation, this presentation is basically a subset of the workshop that I had planned for JSHeroes. So I'm Andrei Pfeiffer. I work as a co-designer for this company called Espresso in Timisoara. I'm also an event organizer. I organize tim.js, which is the local meetup in Timisoara, similar to JSHeroes in Cluj. And I also organize revo.js, which is a 2-day conference in Timisoara, and just like JSHeroes in Cluj. And I'm going to talk about revo.js a bit more in a moment. And from time to time, I also write technical articles on Medium, mostly focused on React Native or JavaScript. So speaking of revo.js, as I said, it's a 2-day conference that's hopefully is going to take place in October this year. And we already have a pretty amazing line of speakers that are confirmed, but we want some more. That's why we have a call for papers that's currently open, and I would like to invite everyone to submit your proposals. It's on the website. You can it's revo.js.ro/2020/CFP. The call for papers is open until I think the 1st of June or something, so it's plenty of time. Also, tickets are not available yet, but they will start on the 1st of May. So in case you want to stay updated, just follow us on your favorite social network platform, or check out the website at revo.js.ro. And if you have any questions, just feel free to ask me, or drop us a tweet or an email.
I noticed you don't have a TikTok account. Sorry for interrupting.
Oh yeah, I don't have a TikTok. Yeah, we don't have. Yeah, do you have for JSHeroes?
No.
Okay. So before we start the presentation, so just to give you a very few a bit of a context. So today's talk is going to be about 15 minutes theory, some slides, and about 45 minutes coding. So before we jump into that, what is memoization? Probably many of you know, but just let me give you a bit of a recap. So citing Wikipedia, memoization in computing is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cached result when the same input occur again. So let's take an example of a factorial function. A factorial is a factorial function. Usually it receives an input, an integer as an input, and returns that input multiplied by all the numbers less or equal than the input. It's used for, I don't know, calculating permutations or combinations in mathematics. It doesn't matter exactly, just a function that receives some input and returns some result. One thing to mention is that memoization is only applicable to pure functions. Pure functions are functions that only depend on the input they receive and always return the same result for the same input, and they don't create any side effects. So let's consider that we call the factorial function first. We search if we have already stored the result in the cache. If we don't, then we have to calculate and to store the results in somewhere in the cache. We call it again with a different input. We have to we do the same thing again. We search. We don't have the result stored. We calculate and we store the result. Then at a later time, when you call that function again with the same input 6. We can return it directly from the cache because we have already calculated that result. So we don't have to recalculate it again. In memoization, a cache is not like a persistent cache. So you don't store the results in a database or on the disk. You usually store it in memory. It's an in-memory cache. And a very simple example for our function would be like an object where the key is the input and the value is the calculated result. So as you probably imagine, if you run the program long enough, this object will start to get really big, right? Because you store a lot of results. So this could be a problem in certain situations. So let's consider that if we don't have any memoization, the time to calculate a certain input takes a certain amount of time. If we have memoization with very few stored results, then probably it takes very little time to search for that result to see if we have a result stored. And of course, if we have it, then we return it immediately. But if we don't have it, then we have to calculate that result. So you can see that memoization adds a bit of an overhead, right? Because now it takes a bit longer to return the result, because we also have to perform some search before. If we have many stored results, then probably it will take even more to search for that result. In the case where we don't find the result, then we have to calculate it. So it could basically affect us even more than not having any memoization at all. So I have to be very careful about when to use memoization in computing. That's why usually all memoization techniques have a maximum cache size. So you specify like only store a maximum amount of results. Don't store all of them, just to avoid any of the problems that I just presented. Okay, so what does this have to do with React? Well, in React 16.6, React.memo was added. Is an API that uses memoization to optimize the performance of function components. And in 16.8, along with the hooks, there were two hooks added: useCallback and useMemo, that also they also use memoization. And well, basically, these methods were added to React's API in order to help developers optimize the rendering performance of their applications. And we're going to talk about all of these methods today. One bit of a note here: all these APIs are only applicable to function components. For class components, there are other APIs and other methods that you can use to achieve the same results. So just a quick example. Let's say you have a function component account that displays some stuff. If you want to use this memoization technique, you basically won't export the component as you would normally export it as default. You wrap that component into this React memo that we're gonna take a deeper look in a moment. So this works similarly as a pure component works for class components. It's just the exact effect. It's only, but React memo is used for function components. One thing to mention: the cache size of all these APIs is 1. So you cannot, React doesn't store multiple results for these memoized methods. They only cache the last result. And that's why you're going to see that you will need to specify when to recalculate. I mean, the first time you use it, React will memoize, will basically cache the result, and you will need to tell it when to invalidate those results. But we're going to see in more detail in a second. Okay, moving forward, let's say that you have another component that and inside of it you need to calculate some factorial or some function that could take a long time to run. So if you want to memoize this the result of this function, you could use React useMemo, which takes 2 parameters. The first one is a callback, is a function which result should be cached, and the second is an array of dependencies. So you basically are telling React useMemo when to recalculate the the result of this function. It will basically say that in this case, I pass in this variable on R, and whenever this thing changes, this function should be recalculated and the result put into this constant that I created. I also mentioned the useCallback at the beginning. So the difference between useMemo and useCallback is useMemo basically executes this function, the first parameter that we pass. useCallback returns a memoized callback function. This is the only difference. And also useCallback is basically a more specialized version of useMemo. We can rewrite this this line of code here using useMemo hook. Basically, you return, you pass in a function that returns another function. Basically, the effect is the same. But enough with the theory. Let's jump into the code because I think it's going to be much easier to understand how everything works. So I have here a very small application. We have some toggle here at the top, and we have a list of items. And each item has some text. It's a very simple data structure and a button that increments something here. Let's open this. I mean, I don't think we need this at the moment. Okay, so having this application, everything is really snappy. Probably it's a bit more difficult to see, but everything works really fast, right? And because we have this application doesn't do a lot. It doesn't have a lot of elements. It doesn't do a lot of heavy computations. So let's, instead of rendering 5 items, let's render 100 items. So now I have more items on the page, and if I press these buttons here, everything works again really well. I mean, really fast. Again, we don't have any performance problems. So if we look a bit at the DOM structure, so it's true that we have a lot of elements, but the elements are very simple, right? We have only some divs and a small element, and that's it, right? And a button. So there aren't many elements in the DOM. So, but this is not a very, a real case scenario, because in a real application, you would have much more elements used either for styling or for layout, right? So your regular applications are not that simple. So I have created here. Well, first of all, let's go through the application just to so we are on the same page. Okay, so let's open the components. So we can go through the structure of the application very quickly, so we are on the same page. So I'm rendering an application that receives an array of items. This array of items is a very simple data structure: a name, a description, which are 2 strings, and a quantity property, which is a number. These are passed to the app, as you can see here. Now, if I go to the app component, I have a label and an input, which are these 2 at the top, and I have a list component that receives the list of items. If I go to the list component, I see it's only a table that renders in the body. It renders a list of items. And each item is a table row with some table cells, and yeah, I have the button that increments this count here. So here I have a very special name component that receives this prop, and if I change this depth to 1, and if we look at the DOM at the DOM tree, you'll see that each letter of this title is wrapped in a span element. So if I pass 2 here, each letter is wrapped in 2 spans. So I basically simulate more elements being in the application. So let's put here, for instance, let's say 10, depth of 10. So each letter of this string here is wrapped in 10 spans. So I have much more HTML elements inside my application. Now, I don't know if you notice it on the stream, but now when I push those buttons, it takes some time to see the updated result in the page. The same with this toggle checkbox here. So in order to show you what this, because it takes some time to get it done, let's go to the profiler. So React DevTools has this profiler that we can use to profile our application. So if you open the profiler and you start profiling and you start clicking your application and you stop it, then we can see here I clicked 3 times, and you can see each state update represented here. So you can see that the render duration of all the application took 120 milliseconds, which is like a lot for just to update like one very small string on the screen. So what's the problem here? Because if we look at the DOM tree and we look at this element here, we can see that when you push this button, only this particular cell updates. You can see that it's highlighted here in the DevTools when I push the button, because the DevTools highlights when an element changes. So even if only this element changes in the DOM, it takes also a long time to get the result there. And the problem is that it's basically how React treats state changes. React is really dumb in updating the DOM. And when I say this, I mean that it doesn't know what actually happened, what actually changed. So it doesn't know that when I push this button, it should update only this small part of the application. This is, for instance, in Vue or in Angular, they are much smarter in this regard. They know what needs to be updated, but React needs to compute, needs to calculate what DOM updates it needs to do. And it does this through the reconciliation process that you probably heard of. So basically, you have one virtual DOM that is created when you initialize the application. The virtual DOM is a data structure that contains all the structure of your application. When you do some state change using setState or using the useState hook or whatever change you do to the application, React creates another virtual DOM, a new virtual DOM. Basically, it has to compare the two in order to figure out what are the minimal updates that it needs to perform. And when it creates this virtual DOM, this is performed by basically executing all of your functions in your application. So every component, so this name component, this is a function. This item component, this is a function. Every element you have in your JSX syntax, this is a function. The small tag is a function. Everything is a function. So basically, when it creates the DOM tree, it needs to execute all these functions. So you're probably seeing all these spans here that I have in my DOM tree. All of these are functions that needs to get executed. So the more you have, the more time it takes, right? Even though nothing, so consider this toggle, for instance. React needs to calculate everything in the entire application, even though I only change this small thing here. So this is basically what we need to accomplish today, to tell React that it doesn't need to re-render some parts of the application when it doesn't need to. Okay, so going back to the profiler. So let's do another profiling where I toggle once this this checkbox here, and once when I push this button here. Probably you can see a small difference between the two updates. So the first one is the one that I clicked the toggle, and the second one is when I clicked the button here. And when I click the button here, you can see that the app here is in gray, and it reads did not render during this profiling session. But when I click the toggle, it re-rendered the app component as well. So let's go to the app component and take a look at our application structure here. So as you can see, when I toggle this this checkbox, the state that is toggled is defined on the app component. But when I push these buttons here, those buttons are inside the list component, which is a separate component. So React is smart enough to some extent to know that it only needs to re-render a part of the entire application, so a subtree of the application whenever the state update took place. So in this situation, because the input, the checkbox is on the app component, it needs to render the entire application. And when you update, when we update something inside the list component, then only the list component and all its children needs to be rendered. So the first thing that you could do, and probably is something that you can apply without any knowledge of rendering optimizations, is you could create a new component, a separate component only for this toggle, and to put the state inside that component. So basically, if I would take this code and create a new component, then when I would toggle, when I would change the state of this toggle, it won't re-render all the other components, because it will only update the subtree of this small component. But in case I would need to access the state from the application component, then I would basically need to put the state back in the function component. So basically, I'm back to square one, so it doesn't fix my problem. So let's take another approach. So as I said, when I click this toggle here, I don't need to render the entire list because it doesn't change. So if the list doesn't change, I could instead of exporting the list, I could export a memoized list using the React.memo API. So if I go and do another profiling, now you can see that here I see the list component, and it's also mentioned that it's memoized. You can see the memo here, and it reads that it did not render during this profiling session, right? So basically, only what was rendered. Maybe yeah. Let's look at the rank chart. So only the app component, the input component, and the label were re-rendered during this state change. The list, the table, and everything below wasn't rendered. So this was very fast. It took only 1 millisecond to re-render. So basically, a part of our problem was fixed only using this this API to memoize our list. Cool. But when I press these buttons, let's profile this again. when I push these buttons, I can see that even if I only change the state of one item here, I can see that all the other table rows are updated. So when you look at this profiling tool, whenever you see gray, that means that it wasn't rendered. When you see some color, being this, I don't know, cyan or green or whatever it is, or if it's this orange, it means that's the component re-rendered. So this is not good. So let's fix this problem in the next step. So let's tell React not to render. I mean, to only to render the item that that was basically updated. So let's apply the same principle that we did here. Let's apply it to the item, because in our list component, I render a bunch of items. So let's also apply React.memo on the item component. Now, let's do another profiling session. And you can see that nothing has changed, right? So it didn't fix our problems. All the components are still re-rendered. If you would like to see which components are re-rendered, you can go here in the settings, and I think it's in the general tab. There is this checkbox that says highlight updates when components render. So now when I click this this button, you can see these things updating here. Okay, so we don't know why exactly our components all these table rows are re-rendered, because we put React.memo here. And well, React.memo, what does it do exactly? As I said, it works similar to pure component for class components. So it looks at all the props it receives, and if any of the props changes, then it will do a re-render. But if any of the props or if all of the props didn't change, then it won't re-render the component. So you have here an item, which is an object, and an increment that is a function. So let's see how are these passed. Well, the item is an object. This is passed from this mapping here of the array. This is not a problem because this is the updates. The increment works similarly to how you would use Redux. I used here a user reducer. I won't get into the details because it is out of scope, but it works similar like Redux. So this is not a problem. Also, there is this increment function that is passed, that is created here, and we only pass the reference to this increment function. So let's, if you go to the settings here in the profiler, you have another checkbox that reads record why each component rendered while profiling. So let's check this one and do another profiling session. So if I go to the list component, you can read here, why did this render? So it says hooks changed. Okay, this makes sense because some hooks changed, so okay, makes sense. But let's go to an item component. So it says here, why did this rendered? Props changed ink. So basically this prop here, or the function that was passed to ink, this changed between two renders. And this happened because list is a function, and every time we call this function, it will execute it, so it will create a new function. So this increment function is created again every time we render the list component. And we basically pass in a different reference of the function. So of course, this changes between two renders. So this is why all the item components are re-rendered. So what we want here is basically to always pass the same reference to the item components, because this doesn't actually change between two renders. It will make sense to move the function outside of this component. So let's say somewhere here. This would fix our problem because now we would have only one reference that won't change between two renders. But we don't have access to this dispatch, which comes from my use reducer hook. So this is not good. So let's try a different approach. Instead of passing the increment function to our components, let's create a new optimized increment, which is a React.useCallback. And as I said, useCallback receives two arguments. First is a function that should be memoized. So our function is increment. And the second is an array of dependencies. So when do we need this this function to return a new reference? So basically, we don't want to return a new reference only once, right? We don't need this function to return a new reference. So if we pass this optimized increment to our item component, and let's do a new profiling session, you would see that all the items didn't re-render during this profiling session. And if we go to the second re-render, we can see that the second item component re-render, and in the first update, only the first one rendered, right? And you can also see here in the UI that it is highlighted what elements are re-rendered during this state update. Okay. So two out of three. Let's for the last part, let me make a quick change to the second item here. So in this description, I have this description here, and I will modify it. I will add more letters here. We'll see in a minute why. Okay. So probably you saw I have here some emojis that are displayed. They are displayed based on some regular expression that I'm gonna present in a second. But if we do, let's do a profiling on the re-render. 1 second. Let me add a bit more C's here. Okay, let's see now. Okay. So when I incremented the first item, it took 7 milliseconds. When I updated the second item, it took like 1 second and something. So it's a really huge difference between the two. Now, I don't know exactly why this happened. I mean, I know because I wrote the code, but let's say that you don't know why something renders, why it takes a long time to render. So it's not something that is coming from our React code that is executed. It's not something that comes from React rendering or something. Let's go to the performance tab for a second. You can do also profiling using the performance tab from React DevTools. Just click some buttons to make some updates in your applications. And then let me expand this a bit. So here on the timeline, whenever you see these yellow spikes, this is scripting. Scripting means that basically it's time spent executing JavaScript code. And you can see this huge blob of yellow which occurred when I clicked this second button. And you can also see this red here telling you that also this is a long task. It took like more than a second. So here, if you have this, it's very important to not have this checkbox enabled. So not to disable JavaScript samples. And if you don't have this checked and you go here in the, I think in the bottom up, having selected the part of the code that you can see that okay, this is not good. When you see something like this, a lot of yellow, it means that a lot of JavaScript code was executed during this period of time. And you can see here that there is a regex that is executed that took a long time, like almost 1.5 seconds. And this comes from a problematic regex, which comes from item component, right? So basically, it knows what was executed during your application updates, and can pinpoint the exact line of code where this took place. So in my situation, it came from this item component where I execute this problematic regex, right? So this is the code with the problem. So let me go to my item component to explain you in a second what is going on here. So this is it's a very simple but stupid regular expression that if you pass a certain string to it, it goes into a really aggressive backtracking recursion, and it takes a long time to execute. So whenever you have some function that could take its potential to take a long time to execute, like I don't know, transforming some large strings or parsing huge markdown on, or large images, or processing large images, or anything that any function that could take a long time to run. This is a good place to add memoization, to memoize the result of that function, especially when the result doesn't change that frequently. So in my situation, in my use case, this regex that displays one emoji or the other, it doesn't matter exactly what it does, so that's not a problem. It receives this the description of the item. The description of the item is this this string over here, which doesn't change when I press this this button here. Pressing this button only updates the quantity. It doesn't affect the description of the item. So this basically doesn't need to get re-executed every time I re-render the items. So it's a good place to use memoization. So we can use the other React useMemo. So this is a hook. It's different from React.memo. React useMemo is a hook that is used inside the components. And useMemo works just like useCallback. It receives two arguments. The first is a function that returns your result, and the other is an array of dependencies. So I would like this this function to be recomputed whenever this item description changes, because the description is a dependency basically of this function that I'm trying to call. In my use case, this will never happen, but it's always good practice to put the dependencies in your memoized methods in order to avoid any problems on the long run. Otherwise, if I don't specify this here, whenever item description will change, I will always get the previous or the first calculated result. It won't be recomputed, which I don't want that. Okay, so I have replaced the isRegex with this memoized version of it, and let's go. I mean, let's do another profiling here. Go to the performance, clear, hit stop, and right now you can see some yellow spikes, but they are basically the same height. It takes really a short amount of time, 19 milliseconds to update or to run JavaScript. If I go to React Profiler, the same thing. I see that all updates are rendered in a few milliseconds. So let me go back to the presentation, if I can find it. Okay, so one thing to notice is that, or to keep in mind, is that any performance optimizations should be treated like antibiotics. When you take antibiotics, I mean, you should take antibiotics when you have a problem, when you have a bacterial infection. You won't take antibiotics when you have a viral infection or a fungus infection. You only take them when you have bacterial infection. And you have to take into consideration that antibiotics are bad for you, right? They destroy your stomach, they destroy many good things about the human body. But you take them because, well, the situation is like really bad, right? So it's you need to kill that bacteria because the bacterial infection is much more dangerous than the harm that the antibiotics does to you. So this is the same as the memoization is basically the same thing. It will add overhead to your application. So you shouldn't use it if you don't need it. So basically, you would only use all these methods that I presented here when you notice a problem, a performance problem, and you can measure it and you can prove that it really takes place. And before making any optimization, you should measure before, make the optimizations, measure afterwards to prove that, well, what you think you optimize actually has a positive result. With this, I thank you. This was my presentation for today. You can follow me on Twitter, on Medium, revo.js.ro, and if you have any questions about React, about optimizations, about revo.js, I'm here to answer you happily. I think we can let persons unmute themselves now.
I think there's a question in the chat room. Somebody asked if React.memo uses shallow compare for props.
Yes, it does. Exactly like a pure component. This is the short answer. Yeah, it does. It does a shallow comparison.
People can unmute themselves now. Sorry for the delay.
Hey, thanks for presentation. I would like to ask about shallow compare. What is, from your point of view, the best practice for compare maybe some other than primitives? I mean, compare part of object.
Well, objects are references, right? Just like functions. So let me go quickly into code here. So have you used the Redux or set state?
Yeah. To explain my question, I'm sorry. I have a problem in the real example. I have a context, and each second came a new result in context from, let's say, server, right? And the state in context is like an hash map, an object hash map, and some of keys, some of values of some keys are really changed on every second, but some not. And I have a list like your table, and each key represent one of tables row, and every second I have a like a tick for to re-render the table, right? And I cannot find the best solution to compare if I need to re-render every row, you know.
Well,
so to make a bit more clear, I subscribed so every row subscribed to context, and every time, every second, the new object came from context.
Well, okay, it's a bit difficult for me to visualize your exact use case. The thing is that let's just assume that you have some object in this is your context, right? You have some object there, and let's say you have some
some state there,
some list that is an array of, let's say, other objects. This is some very deeply nested data structure, right? Because this is a reference, this is another reference, this is another reference, right?
Yep, let's say.
Okay, so let's say that you only want this to update. You are making an update to this element here. So,
okay.
So let's say this is okay. So you won't do something like this context of list of 0 dot I don't know, some prop equals something. This would mean that you basically make a mutation in this of this reference here. So React won't know to update that to make a re-render. This is some like a fundamental thing about React. And if you use state or use if you use Redux or this is basically like a fundamental thing that you shouldn't do something like this. So you basically would need to return a new reference of the context in this situation. So you have to return a new reference of this object, and you have to return to make list like being a new array. So this array should be a new reference, and you should return a new reference of this object, and you basically would need to leave this reference untouched because you don't want them to be re-rendered. I don't know if it makes any sense. I mean, probably it would be much easier on your use case, but it would take me a lot longer time to understand the context. I mean, I understand your use case, and to but you can drop me on either a message on Meetup or on Twitter, and we can discuss in details if you need help with.
Yeah, I think it will be much better.
Yeah, because
okay, I will prepare my question and post somewhere. Thank you for reply. Anyway,
no problem. No problem. Any other questions?
Yeah, I have a question about the profiler. In your scenario, your application is kind of simple, right? Not
Yeah.
much. But what if you want to do profiling in a very big application? I'm guessing you'll have a lot of graphs and calls and code running. Is it easy to spot in that scenario what function is hogging the CPU, or I don't know?
You are referring to this profiling using the performance tab. So
Exactly. How will it work in a bigger application with lots of calls?
well, this is the thing, because this thing here. So let's go back to the previous example. This is the beauty of. I mean, they are really smart. The people from the Chrome DevTools. So let's profile this once again. So as you can see here, this is a so-called bottom-up display. So it shows you like the most inner function that got called, that so not all the ancestors. So it tells you the most deepest function, and then you can go outwards. So item called item used this problematic regex and so on and so forth. So it will pinpoint to the exact problem. So you can go from the very deep, the very guts of your application. You can go step by step out. More to the surface. I don't know how to describe. So it's not a problem. I mean, if this was a big application and this function was called from, I don't know how many levels deep of components. You understand
Yeah, the bottom up thing makes sense. So
yeah. So this is like really useful.
nice. Thank you.
Yeah, no problem. I mean, this was a bit of was a bit out of context. It wasn't. You probably don't need this in the context of React. This was only to show you like how you can pinpoint some problems with your code. It's not something that is related to React. You can use it in any other kind of application. When you don't know the application and you don't know what's actually happening, this could help to identify some problems.
Do you know some articles, maybe videos to deep dive into Profiler?
Adios Money, I think, released an article like a few days ago.
I think the Google developer portal is a good resource for that, because they explain there at least how the profiler works in Chrome and what you can look at.
That old one course from Google. I've seen the old one course, online video course from Google.
Yeah, they have video courses for that also, but I think it's, if you go to developers.google.com, there's a...
I've seen one from Google. It's old one, but it's a really good one.
So I saw, I think this week or last week, I don't know exactly, this blog post from Adios Money, exact profiling React apps. It shows some more in-depth stuff that you could do. But this is only for React. You are looking into the Chrome DevTools, right?
Nope. This one also good.
Okay, I can paste it in the chat. But as Alex mentioned, Google developers, I don't know exactly where they put their resources, but they have a lot of. And I also saw something, but
I'm pasting the link in the chat also for this one. If you look at on the sidebar, they have really good documentation on all parts of performance, rendering, loading.
Oh, Jeremy Wagner, nice.
So you can open on the left side, you can open like there in the loading performance, rendering performance, all sorts of like information and documentation about what to look, and it's a lot of reading if you want to really get.
Yeah, I can see. Nice. From me to Alex Moldovan privately. Everyone. Okay.
So yeah, thanks Andrei for the presentation. It was really, really nice.
Yeah. Glad to. Thank you for inviting me, and hope it was useful for at least for some of you.
It was.
I'm glad.
It was really nice. Thank you.
Thank you. Thank you.
Thank you very much. Thank you.
Very useful. Thank you.
You can ask more questions if you have.
I would have one.
Yeah, sure.
Would you use this profiling also for React Native?
Yes.
I've used it a bit, but I don't know. It's for me, it was a bit hard to find the functions that I was looking for. What are you? This is what you would use as well for React Native?
I actually, all these methods that I presented here, I use them for React Native because I'm working with React Native. So yeah, I definitely recommend. But I mean, it's the same. The React works the same. The reconciliation process is the same in React Native. So yeah, I'm using the React Native debugger, but this basically this is like an Electron app of. You have the same profiler as you have in the browser. It's basically the same, that it's put in an Electron native application, but it's the same. The same. It works.
Oh, okay.
Sure. Definitely.
Okay, any more questions? Anybody?
I'm curious, what else did you have planned for the workshop? Like, what were you adding?
Well, of course, the workshop would have been a much slower pace. I also have here a slide. So I would have gone into much more detail about the reconciliation process, about keys and how to use and how to not use keys, how to use keys or how to abuse keys to force re-renders in some situations where you cannot re-render something. How to use the use ref hook in order to skip to not re-render when you don't need to. Also, this is like a performance optimization that I used in some situations. And React.memo also has a custom update function. So the second parameter, React.memo receives two parameters. The first is the component, and the second is a function, is an optional function that we can pass. That is similar to the should component update lifecycle method in class components. So basically, this is the second parameter is the inverse of should component update. It tells React.memo when these components are equal. So it's like in the negated should component update. So when you return true, these are, it won't re-render. And when you return false, it should re-render. Should component update is basically the exact opposite. When you return true, it should update. When you return false, it will not update. So I also have a use case for, in my workshop, I had a use case for this. So, yeah.
And what do you get as the arguments? Props and state, or?
You don't get you get the props. You get only the props, I think. Because you can handle state differently in function components. React.memo. Only the props, I think you get. Are equal. Ref props, next props.
Oh, okay. Actually, it makes sense because you have hooks for state and.
Mm-hmm. Exactly. And of course, exercises and more practice.
What are keys?
Keys, the ones that you use when you render collections. You pass in a key to the items.
Oh, okay. I get it now.
Those keys. Oh, not this one, sorry.
Do you have a quick example of how do you optimize using keys?
Well, keys are basically, so if you specify a key, a unique key, you already optimized. I mean, during the workshop, I only tried, the thing was that to get into the details of why React asks you to pass a unique key, and what happens if you don't pass the unique key, and what happens when you don't pass keys at all, and how does it treat keys. So it's basically like a deep dive into how keys work. And also, there is one situation where I encountered in a React Native application, but I also have an example here. Let me check if I can. Oh no, I don't think I can demo it. So if you consider that you have an iframe somewhere in your application, right? And you pass in some URL, let's say http google.com, okay? And so the user would be able to navigate in this iframe, right? So it will navigate, it will go to another page, to another page, to another page. Now, let's say that you want to reset this iframe to the original URL that you passed here. it could be, and it is very tricky to do this because iframe is basically a component that you cannot control, right? So if you would, I mean, you can have a ref to the iframe, and you can use the browser API to I don't know, to call the history state to go back, but you don't know how many pages has the user navigated, for instance. So what you could do is you could pass a key here to this element, let's say a count or an index or something, and you could force a re-render of this component whenever you change this key, because React, when you change the key of an element, it will basically re-render it. It will take it outside the DOM and will remount it again. So this is like I used to call it a hack, but it's not actually a hack because it's also documented in some React or by Dan Abramov or by somebody from the React team. It's also documented a workaround to force re-renders on your components. So yeah, this is
actually, I've seen this approach on a project I worked, and I thought at first that it was a hack, but actually the person who did that used a component which was controlled, and you passed a non-change and a value to it. But the problem is that component had a bug, and it did not update itself when the value changed. So as a quick fix, it gave it a new key each time the value changed from the outside, and the component will re-render. And I was like, whoa, that's actually genius.
Yeah. So yeah, I mean, yeah, if you understand how keys work and how React treats keys, then basically you have more knowledge in your briefcase, and you can use them in I don't know, specific situations that you might encounter. I use this, for instance, in React Native application, having a web view. Web view is just like a sort of an iframe that you display like a web page in a mobile application, and the same thing, like the user could navigate, I don't know, to what other page, and you want to take him back to reset the web view or the iframe to the original URL. So this is something that I used. Can see Dodds also has another use case. Can see Dodds React keys understanding. Yeah, this is like another good article. He presents another use case that's where updating the keys to force a re-render worked for him. I will paste this here in the chat. Thanks, Lucas. I don't know if you're around still.
I also need to leave, but yeah, thanks again. See you around.
Yeah, sure.
Next meetup, and hopefully in flash in October.
Fingers crossed. Fingers crossed. Okay, so I think we can call it. If there are no more questions.
Will the presentation be posted on the group?
It will be added in on our YouTube channel.
Okay.
Andrei allowed us to record it, and we're gonna post it there.
Yeah. Thank you. Sure.
Cool.
Thank you, Andrei.
Okay.
Thank you. Thank you. Thank you everybody for attending. And yeah, see you next time. Have a great evening.
Bye bye.
Bye.
Thank you, everyone.
Have a day.
Thank you. Bye. Bye.
Bye.
Thank you.
Thanks.
Thank you.
Bye.
Bye. Thank you.
Bye bye.